So here we have a system of equations. I have x plus y equals 1, x minus 2y equals 4. If we have to use the calculator, the very first step would be to rewrite in slope-intercept form. So I am going to keep y on the left-hand side and move x to the right-hand side. So positive x would now become negative x, giving us y equals negative x plus 1. In a similar manner, the second equation, negative 2y, would equal to negative x plus 4. Multiply by negative on both sides, 2y would be equal to x minus 4. Negative times negative 2y is positive 2y. Negative times negative x is positive x. Positive 4 times negative 1 is negative 4. And now we have to divide by 2 throughout. So 2y over 2 equals x over 2 minus 4 over 2. So y would be equal to x over 2 minus 2. And you can see the moment I saw a fraction, I put it in parentheses. That is good practice. You have to rewrite it in the way we did if we are going to graph it to find the solution. So we are going to type in the two equations that we rewrote using the original equation, or the original system, I mean. The first one is y equals minus x plus half. The second is y equals x over 2 minus 2. So we have our two equations, and note that I used parentheses the moment I saw a fraction. So good practice. If you don't do that, you will make mistakes in a quiz or on an exam. So I'm going to hit graph. Oops. So if you want to specify negative x, you have to use the negative that's right next to the enter button. So graph. Clearly, the two lines do intersect, and we want to find the point of intersection. So I'm going to hit the math button. Second mode. I'm sorry, it's not the math button. It is second trace. Second followed by trace. Trace is the second button on the top from the right-hand side, right next to graph. If you look at option number 5, it says intersect. So 5. Once you hit, or once you select 5, it is going to ask you to move the cursor so that you select the first and the second curve. So the cursor is right over there. I'm going to move it and say that line is my first curve. So hit enter. Now it's set a point, and there is a blinking cursor on the second line, and I'm going to hit enter that as well. So I have selected the two curves, and in the bottom of the screen, it says guess. So hit enter again, and it is giving me the point of intersection. It is 2.6667, and y is negative 0.6667. So those are the two values that we have. So the value of x is 2.67. The value of y is negative 0.67. Negative 0.67 is simply negative 2/3. And 2.67 would simply be 8/3. So x is 8/3 and y is negative 2/3. We want to know if we have the correct solution. Is it 8/3? Yes. So it's 2.667 and negative. I'm just going to verify this. Okay, negative 2/3. That is correct. My equation's right, x/2. Aha. I believe we had 1 and not 2. It's negative x plus 1 and not 2. I apologize. Something looked odd over there, so I entered the wrong number here. So it is negative x plus 1. So we'll go and fix the solution in a bit. So graph again. Point of intersection is there. So second trace, option number 5. It is asking me to select the first curve, so enter. It's asking me to select the second curve, enter. And it says, should we guess? I'm going to say enter. So the intersection is 2, negative 1. So x is 2 and y is negative 1. The calculator is probably correct, but how did I realize that I made a mistake? The moment I got the solution, I looked at my first equation and I tried to plug the values that we got in the first equation. And when I did it in my head, it did not work, which is why I stopped and went and checked to see if I made a mistake somewhere, which I did. So now we have the correct answer. So let's see if it works. So the first equation is x plus y equals 1. Plug in x and y. 2 minus 1 equals 1. 2 minus 1 is 1. 1 is equal to 1. It checks out. It is correct. X minus 2y equals 4. X is 2. Y is negative 1. 2 followed by minus 2 times minus 1 is plus 2. So we have 4 equals 4. That checks out too. So the answers that we got via graphing is in fact the correct answer. So first step would be to rewrite. Minus y would be equal to negative 4x plus 6 multiplied by negative on both sides. Y would be equal to 4x minus 6. Second equation, minus y would be equal to minus x multiplied by negative on both sides. Y is equal to x. Mind you, we want to rewrite it this way if we want to solve it using graphing. If we don't want to use graphing, then we don't have to rewrite it. So the two equations are y equals 4x minus 6 and y equals x. So y equals 4x minus 6, y equals x. Let's graph it. So the two lines intersect. So I'm going to press second trace, option number 5. First curve, it's blinking, so enter. It selected the first curve. Enter. I'm going to select the second curve. Done. Now hit enter again. The intersection is 2, 2. Let's see if I typed everything right. Okay, 2, 2. Did you meant to say 2, 2? The person who said 2, okay. The answer is 2, 2. Let's say if we got the correct solution. So plug in 2, 2. It's the very first equation. 4 times 2 minus 2 equals 6. 8 minus 2 would equal 6. 6 is equal to 6. Checks out. We're going to take 2, 2 and plug it in x minus y equals 0. So 2 minus 2 equals 0. 0 equals 0. It works out. So we have the correct solution. So we want to rewrite in this case, as always, since we're using graphing. So minus y would equal to minus 3x plus 4. Multiply by negative on both sides. Y would be equal to 3x minus 4. Same, minus 2y will be on the left-hand side. I'm going to move the positive 6x to the other side. So I have negative 6x plus 8. And divide by negative 2, y equals minus 6x over minus 2 plus 8 over minus 2. Minuses would go away. 2 and 6 will get cancelled. So we have 3x minus 8 over 2 is 4. And you can see both of them are exactly the same equation. So this system has infinitely many solutions because we're talking about the same line. So a line can intersect with itself infinitely many times. So we don't have a point of intersection in this problem. Unique solution. So there is no unique solution. And there is no need to graph either, because if you did y equals 3x minus 4, which is the first equation, and the other one is exactly the same, 3x minus 4, we just have one line. So a line is being drawn onto itself. So if you want to say intersections, well, I could plug in any set of numbers that are on that line to say, oh, all of those would be solutions. So there is no unique solution for that problem. So here, the two lines are parallel, and we know the parallel lines do not intersect. And the solution to a system is the point of intersection. So if we have parallel lines, we have no point of intersection, so we're not going to have a solution. So let's go ahead and rewrite. So minus y would equal to minus 3x plus 4, which would mean y if I multiply by negative on both sides, y would be equal to 3x minus 4. Likewise, negative 2y would be equal to negative 6x plus 4. Multiply by negative on both sides, 2y would be equal to 6x minus 4. Divide by 2, so y would be equal to 6 over 2, which is 3x, minus 4 over 2, I get minus 2. Just by looking at the equations, we should be able to say that lines are parallel to each other. Parallel lines will have the same slope, and they do have the same slope. So you can verify this via graphing also. So y equals 3x minus 4, y equals 3x minus 2, graph. They are two parallel lines, and so they do not intersect. So I could, of course, use the trace function and try to find an intersection. So I'm going to select it on the first curve, enter, second curve, enter. Now I'm going to ask the calculator to guess, and it says error, no sign change. In other words, the lines are parallel. It doesn't have a solution. So here, oops. So the lines are parallel, so that there will be no point of an intersection. No point of intersection simply means no solution.